Metals, nonmetals, and metalloids. Remember that all metals are located to the left of the stairstep on the periodic table of elements, and the atoms have identical arrangements of electrons with similar properties. Metals' properties are good conductors of heat and electricity. They're malleable, which means they can be hammered or rolled into sheets, and all but mercury are solid at room temperatures. The most reactive group of metals are the alkali metals in group 1. This means they react rapidly and sometimes violently with oxygen and water. Because they are so reactive and can combine so readily with other elements because of their one electron in their outer shell, they don't occur naturally in nature. And if they are found in their elemental form and made in a lab, they have to be stored carefully in a chemistry lab. Alkaline earth metals make up group 2 of the periodic table. Like most metals, these metals are shiny, malleable, and ductile, meaning they can conduct heat and electricity. They also combine readily with other elements since they only have 2 electrons in their outer energy level. You've probably seen alkaline earth metals in use if you've ever seen firework display. Magnesium, for instance, produces brilliant white colors, while strontium produces bright red flashes. The elements in groups 3 through 12 are called transition elements because they are considered to be elements in transition between groups 1 and 2 and groups 13 through 18. You see compounds that contain transition elements on a daily basis. Iron, cobalt, and nickel, sometimes called the iron triad, are 3 elements used in the process to create steel and other metal mixtures. The colors of rubies and emeralds are also due to transition element chromium. Copper, silver, and gold, found in group 11, are so stable and malleable they were once used widely to make coins, but for this reason they are known as the coinage metals. Because they are so expensive, silver and gold rarely are used to make coins anymore, and most coins now are made of nickel and copper. The 2 rows of elements that seem to be disconnected from the rest of the periodic table, they are down to save space on the periodic table and are called the inner transition elements, or the lanthanide and actinide series. Nonmetals are elements that usually are gaseous and brittle solids at room temperature. They do not conduct heat or electricity. They are usually brittle and powdery. All nonmetals except hydrogen are found at the right of the staircase on the periodic table. Most of your body's mass is made up of nonmetals. This includes oxygen, carbon, hydrogen, and nitrogen. The electrons in most nonmetals are strongly attracted to the nucleus of an atom, so most nonmetals can form ionic and covalent compounds, which we'll talk about in upcoming chapters. Group 17 are known as the halogens, and their compounds have many uses. Fluorides are added to toothpaste or to city water to prevent tooth decay, and chlorine compounds are added to water to disinfect it. The final group, or group 18, are known as the noble gases. They are extremely stable because their outermost energy levels are full. No naturally occurring noble gas compounds are known, and therefore exist as isolated atoms. The stability of noble gases is what makes them useful. Argon and krypton are used in light bulbs, neon and argon are used in neon lights, and helium makes it useful in blimps and balloons. Now remember metalloids. These are the elements in the periodic table that are located along the stairstep line. The mixed groups 13, 14, 15, 16, and 17 contain metals, nonmetals, and metalloids. Metalloids can form ionic and covalent bonds with other elements and can have metallic and nonmetallic properties. Some metalloids can conduct electricity better than most nonmetals, but not as well as some metals, giving them the name semiconductors. Now note that elements having more than 92 protons, which is the atomic number of uranium, are called transuranium elements. These elements do not belong exclusively to the metal, nonmetal, or metalloid groups. These are the elements towards the bottom of the periodic table. All of the transuranium elements are synthetic, which means they are man-made. Synthetic elements are unstable and many of them disintegrate quickly. Scientists study how the man-made elements form and disintegrate so they can gain an understanding of the forces holding the nucleus together. When these atoms disintegrate, they are said to be radioactive. Radioactive elements can be useful, such as those used in medical applications. All right, let's look around you. Can you find other examples of elements and compounds around you? It's time to show what you know.